Intermolecular forces of attraction. Intermolecular forces of attraction are forces of attraction that exist between the molecules that comprise matter. They are weaker compared to ionic and molecular or covalent compounds. Types of intermolecular forces of attraction. First, dipole-dipole forces. Dipole-dipole forces are intermolecular forces acting on polar molecules. They are short-range forces that exist between molecules that are very near to each other. A polar molecule can induce a temporary dipole in a non-polar molecule by temporarily attracting its electrons. Here is an example of a dipole-dipole forces. Here we have a molecule of HCl and another molecule of HCl. The negative charge in the Cl side is attracted to the positive side of the hydrogen side. Thus, an intermolecular attraction is formed. Second type of intermolecular forces of attractions are the hydrogen bonds. Hydrogen bonds are a special type of dipole-dipole interaction. It results when hydrogen atom bonded to a highly electronegative atom like nitrogen, oxygen, or fluorine is attracted to an unshared pair of electrons of an electronegative atom of another molecule. The boiling points of hydrogen-bonded molecules are higher due to the special ability provided by the hydrogen bonds. Water is a good example of a hydrogen-containing compound with high boiling points. Here are examples of hydrogen bonds. Water is composed of oxygen and two hydrogens. On the side of the oxygen, there is a slightly negative charge. On the side of the hydrogen, there is a slightly positive charge. Thus, the negative charge of the oxygen is attracted to the positive side of the hydrogen, thus forming hydrogen bonds. The third type of intermolecular forces of attraction are the London dispersion forces. London dispersion forces are intermolecular forces present in all atoms and molecules. It results from constant movement of electrons. They are considered also as the weakest type of intermolecular force of attraction. So here is an example of London dispersion forces. We have the chlorine gas in the form of two chlorines bonded together, forming London dispersion forces. Physical properties. Physical properties are characteristics of matter that are observed without changing its chemical composition. They are attributed to the intermolecular forces of attraction that exist between the molecules. Some physical properties includes melting point, boiling point, density, hardness, and solubility. The effect of intermolecular forces on the properties of substance. The strength of a substance's intermolecular attractive force determines many of its physical properties. Boiling point. Higher boiling points indicate greater intermolecular forces of attraction between particles of a sample fluid. Here in this table, we can see different boiling points of different substances. And for this, on this table, we can see that water has a boiling point of 100 degrees centigrade. Comparing it to other substances in the table, it has a higher boiling point. Examples of the effect of intermolecular forces on the physical properties of some substances. Bromine. Bromine has a weak intermolecular force, that's why it boils easily. Water. Water has a stronger intermolecular force. That is why it has a high boiling point. Ionic compounds. Ionic compounds have higher boiling points than molecular compounds. Solubility. A polar substance is only soluble in another polar substance. A nonpolar substance is only soluble in another nonpolar substance. In other words, like dissolves like. Examples: oil. A nonpolar substance is not soluble in water, which is a polar substance. Sucrose, or the table sugar, is a polar substance, is soluble in water, because water is also a polar substance. Sodium chloride, table salt, will dissolve in water because it is a polar substance.